Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 18 Tangents and Intersecting Chords. We will be studying concepts with examples and solve many questions from exercise 18A. Are you ready? Let's start. Let us first understand what secant and tangent of a circle are. Here we have three figures. In these three figures, we can find circles and line segment. In the first figure, we have a circle and the line segment. They do not touch each other. Yes, the line segment does not touch the circle. What about the second figure? In the second figure, we have a circle and the line segment touches the circle at 2 points on the circumference of circle. What about the third? In the third figure, the line segment touches the circumference of circle at only 1 point. Okay, clear what the difference between the three figures are? Now, if the line segment touches the circle at 2 points, then this is a secant. Okay, this line segment is called a secant. If the line segment touches the circle at only 1 point, then it is called a tangent. Understood? So, a secant of a circle, the straight line which cuts a circle at 2 points. Here we have 2 points. Okay. And what about tangent? Tangent of a circle, the line which touches a circle at 1 point only. This point. Okay. Now in this figure, here this line segment CD. Okay. We have the circle. This line segment CD touches the circle at 2 points, point M and point N. Then is this a tangent or a secant? This line segment is a secant of the circle. Okay, it touches the circle at 2 points, here M and N. CD is the secant. Now, FE or EF is a line segment that touches the circle at only 1 point, that is P. Okay, it touches the circle at only a single point, which is P. Therefore, here we have the tangent. Tangent of the circle is tangent EF. Understood what secant and tangent are? So, we understood what a tangent is. The line segment that touches a circle at 1 point is called a tangent. Here, I am having a circle and I am going to draw a tangent. This line is a tangent which intersects the circle at the single point. This point is called point of contact. Point of contact. Okay, the point where the line segment touches the circle. Okay, there are few important points that you have to remember regarding tangents. The first one is, no tangent can be drawn to a circle through a point inside the circle. Inside the circle, I am going to consider a point P. Okay, this is my point P. Using this point, I am going to draw a tangent. Let us see if I will be able to draw or not. Using this point, I can draw a line. Yes. Here, this line cuts the circle. It's not that the line touches the circle, it cuts the circle. So, it is not a tangent. Okay. So, this is not a tangent. Why? Because this point P, which lies inside the circle, can only cut the circle when a line is drawn. It cannot touch the circle. So, using this point, if I am able to draw a line that touches a circle, only then it is a tangent. So, this is not a tangent. This is our first point. Second one and only one tangent can be drawn to a circle through a point on the circumference of circle. On the circumference of circle, we have many points. Here I am considering 1 point. Okay. Using this point, I will be able to draw only a single tangent. This is a line that I can draw at this point Q. Okay. Here, the line touches the circle at point Q. Can I draw any other tangents that passes through this point Q? No, right? Only a single line can be drawn. Here I have taken a point Q. Now if I am taking another point R here, again same thing. I can draw only one line that passes through this point R which lies on the circle. So the statement is one and only one tangent can be drawn to a circle through a point on the circumference of circle. If you consider any one point, only one tangent you can draw. Now the third one, two tangents can be drawn to a circle through a point outside the circle. First case, we have taken a point that lies inside the circle, and in that case we were not able to draw any tangent. Second case, we have taken a point that lies on the circumference of circle, and now we are going to take a point that lies exterior to the circle. Here I have a point M. Okay, this is my point M. From this point M, I am trying to draw tangents. Now this line is the tangent. Similarly, this line is the tangent. Here it meets the circle at this point, and here it meets the circle at this point. Yes, so we are able to draw two tangents to the circle from a point that is exterior to the circle. Understood? So, two tangents can be drawn to a circle through a point outside the circle. Outside, when you consider a point, you will be able to draw two tangents. Okay? Clear? So, the first one, we were not able to draw any tangent when the point lies interior to the circle. And when the point lies on the circle, then we were able to draw one tangent. When you take a point outside the circle, you are able to draw two tangents. Clear? All these statements are clear, right? Next, we have few theorems to discuss in this session. The first one is the tangent at any point of a circle and the radius through this point are perpendicular to each other. Here I have taken a circle with radius OP and tangent AB. Here AB is the tangent, OP is radius, P is our point of contact. Okay, we have to prove that. To prove OP is perpendicular to AB. This is what the theorem states. How to prove OP is perpendicular to AB? Now in this case, if you are considering a baseline AB, we have a point O. With this point O to this baseline AB, I can draw many lines. This is one line. This is another line. I can draw n number of lines. Yes? Okay. Now, here I am considering a point Q that lies on the line AB. Okay. What about the distance OP and OQ? Which is greater? When you look at this figure, you understand that OP will be less than OQ. Okay. Here, I'll be taking this point as some P. This is Q, this is R, this is S. Okay, we have taken many different points. Now, we'll understand that the smallest distance will be OP. Yes, when you look at this figure, it is clear that the distance OP is less than OQ, which is less than OR, which is less than OS. OS is a bigger distance compared to OP, OQ, OR. That is, from this point, when the distance increases, distance from O to S increases, distance from O to R increases, everything increases, right? So, this OP is the smallest, which means OP should be the perpendicular distance. Okay, OP should be perpendicular to AB. So, the perpendicular line will be having the shortest distance. Clear? In this case, OP is perpendicular. Only then OP will be less than OQ. Clear? OP should be perpendicular to AB. What is OP? OP is the radius. Okay? OP is radius. Therefore, we have radius perpendicular to tangent. OP perpendicular to AB. Understood? The perpendicular line will be the shortest line that can be drawn from a point to baseline AB. Okay. Using this, we have shown that the radius is always perpendicular to tangent at the point of contact. Clear? Okay. The statement is clear. Let's move on to the next one. Next statement. If two tangents are drawn to a circle from an exterior point. What is an exterior point? The point which lies outside the circle. First thing is the tangents are of equal length. Second, the tangents obtain equal angles at the center of the circle. And third, the tangents are equally inclined to the line joining the point and the center of the circle. Okay. The tangents are equal in length. Now consider this figure. Here we have a circle. PA and PB are the tangents. We have to show that. To show PA is equal to PB. Why? Because PA and PB are tangents. According to the statement, they should be of equal length. Second, the tangents obtain equal angles at the center of the circle. Here we have center O. Tangent PA subtends an angle POA at the center and tangent PB subtends an angle POB at the center. They should be of equal measure. Angle POA should be equal to angle POB. This is the second one. And third, the tangents are equally inclined to the line joining the point and the center of the circle. So this is the line joining point and center of the circle. Tangent PA is inclined by this angle and PB is inclined by this angle from the line joining the point and center of circle. So we have to show that APO, angle APO is equal to angle BPO. Angle APO is equal to angle BPO. To show this, what we are going to do, we are going to consider the two triangles. Consider triangle POA and triangle POB. POA is this triangle and POB is this triangle. Here, PO is common to both the triangles. Yes, we have PO equal to PO. Common. What else? We have OA equal to OB. What is the reason? OA is equal to OB. Radii of circle. Okay. Then, one more. We have PAO equal to PBO. What is the reason? Angle PAO equal to angle PBO. Right angles. How do we get right angles here? The angle made by tangent and the radius of circle is always right angle. Therefore, PA is perpendicular to OA and PB is perpendicular to OB. PAO is equal to PBO equal to 90 degrees. Okay. So, using the RHS criteria. Remember, here we have a right angle, common hypotenuse and one side equal. Therefore, using the RHS criteria, we have triangle POA congruent to triangle POB. Then using CPCT. What is CPCT? Corresponding part of congruent triangles. We'll be having PA is equal to PB. What is PA and PB? Length of tangents equal. So the first one is proved. Okay. Using CPCT, we get PA is equal to PB. Then angle POA equal to POB. POA, POB. Corresponding angles of congruent triangles are equal. So here we had to prove POA and POB equal. That is, the tangents subtend equal angles. Angles subtended by the tangents at the center are equal. Now the third one, we have angle APO equal to angle BPO. Inclined angles. Angles inclined by the tangent with the line joining the exterior point and the center. They are also equal. Again, this is due to CPCT, corresponding angles of the congruent triangles. Clear? So, we have proved the three statements regarding a tangent drawn from an exterior point. We are having two tangents that are drawn from an exterior point. Okay. Next theorem, if two circles touch each other, the point of contact lies on the straight line through the centers. First case is when the given two circles touch each other externally. Here we have the first circle with center A and the second circle with center B. Okay, they touch each other at point P. Now QP is a tangent to the circle with center A. QP is also the tangent to the circle with center B. Okay, we have to show that this line joining the centers and point of contact is a straight line. We have to show APB is a straight line. How to show APB is a straight line? For a straight line, when you have a straight line, this angle will be 180 degrees. Yes, here if APB is a straight line, then this angle APB should be equal to 180 degrees. Okay. Now, consider the first circle, the radius AP and the tangent QP. For this circle, we have QP perpendicular to AP. Yes. AP is perpendicular to QP because AP is the radius and QP is the tangent. The angle between the radius and tangent at the point of contact will be equal to 90 degrees. Therefore, angle APQ is equal to 90 degrees. Okay. Similarly, when you consider the smaller circle with center B, we have angle BPQ is equal to 90 degree. Same reason, that is BP is the radius and QP is the tangent. They are perpendicular to each other. Here AP perpendicular to QP and here BP perpendicular to QP. Okay. Then angle between radius and tangent is 90 degree. Okay. Now we have angle APB equal to angle APQ plus angle BPQ. Yes. APQ is this part and BPQ is this part. Here we got APQ 90 degrees. It is a right angle. BPQ also 90 degrees. Right angle. Therefore, we have angle APB is equal to 90 degree plus 90 degree, which is equal to 180 degrees. Since angle APB is equal to 180 degrees, what can we say? We can say that line APB is a straight line. APB is a straight line. So, according to statement, we need a straight line through the centers. The straight line through the centers. APB is the straight line through the centers. When two circles touch each other and we have the point of contact P. Here this is a case when the circle touch each other externally. That is, the second circle does not lie inside the circle. Clear? The same theorem, that is, if two circles touch each other, the point of contact lies on the straight line through the centers. Now, this is a case when the given two circles touch each other internally. Consider this figure. Here we have the bigger circle with center A and the smaller circle with center B. The smaller circle lies inside the bigger circle. Point of contact is same. Point of contact P. Okay. QP is the tangent to the circle with center A as well as to the circle with center B. Now we have to show again in this case line ABP is a straight line. How to show in this case? How to show this is a straight line? When you have a line, so this is my line. Here I have a point. How many perpendiculars can I draw from some other point to this point P? Only one, right? So this is my perpendicular. If I have any point that lies on this line, from all these points when I draw straight lines, they will be perpendicular to this line. Yes. Now consider, here we have AP perpendicular to QP. AP is perpendicular to QP because AP is the radius of the bigger circle, QP is its tangent. Similarly, when you take the smaller circle, we will be having BP perpendicular to QP. Now here P is this point. B is a point that lies on AP. Only then you will be having BP perpendicular to QP because from the same straight line we can only have one perpendicular line. Okay. Therefore, this B should lie on AP. Okay. That is A and B points lie on the same straight line. Clear? Here, if you have any other points, when you draw lines, you will be getting perpendiculars. If the line is drawn with some other external points, you won't be getting perpendicular to this point P. Okay, when you draw a line from this point to this point P, you won't be getting perpendiculars. Only from point that lies on this line AP, you can draw perpendicular lines. Clear? Therefore, ABP is a straight line. ABP is a straight line. Clear? So, we have taken the external circles case and they touch internal case. Okay. Next, we have two types of common tangents and the first one is direct common tangents. When I take two circles, so this is my first circle and this is my second circle. Here I am drawing a tangent. Okay, this tangent touches the first circle at this point P and the second one at this point Q. Okay, similarly I can draw one more tangent. Here it touches the first circle at M and the second circle at N. Now, when I consider this tangent, towards the down side we have both the circle. When I consider this tangent, upside we have both the circles. Okay. Now, if these are my circles, my first circle, second circle. Here I have a tangent A, B. We have another tangent C, D. Now, when I consider this tangent AB, both the circle lies towards the right side of the tangent. When I take this CD tangent, we have both the circles to the left side of the tangent. Now, consider these figures. Here we have a bigger circle and a smaller circle. Okay. So, here the point of contact is A. Here the point of contact is B. For the second tangent, we have C as the point of contact to the bigger circle and D as the point of contact to the smaller circle. Same as we discussed this case, we have both the circle which comes downwards to the tangent AB, upwards to the tangent CD. Here again, the same case, but the difference is smaller circle comes first and then we have the bigger circle. Now, in this case, we have two intersecting circles. We have the first tangent touching the first circle at A and the second at B. Second tangent touching the first circle at C and the second circle at D. Okay. In all these cases, we can see that for the first tangent, we'll be having both the circle on one side. For the second tangent also, we have both the circle on this other side. When a tangent common to two given circle is drawn in such a way that both the circle are on the same side. Here, down, when you consider PQ tangent, and when you consider MN tangent, we have both the circle up. Okay. Here, when you take AB tangent, we have both the circle to the right. CD tangent, we have both the circle to the left. Same side of it. The tangent is called direct common tangent. In this case, we call the tangents as direct common tangent. Okay, understood what direct common tangents are? That is, both the circles should lie on the same side of the tangent. Okay, then we'll be having the length of tangents equal. That is, from this point A to this point B, the length is AB and this length CD will be equal. Here again, AB will be equal to CD. Here again, AB will be equal to CD. That is the point of contacts of the tangent with the circle. The length when measured will be equal. Second is the transverse common tangent, just the opposite case. That is, in case of direct common tangent, we had both the circles on the same side. Here, both the circles will be on the either side of the tangent. When you have first circle with center A and the second circle with center B, the tangent will be in such a way that it touches first circle at some M and the second circle at N. First circle, here it lies towards the left side of the tangent and the second circle lies on the right side of the tangent. There is difference, right? Here, both are lying on opposite sides of the tangent. Okay. Here, when you take this figure, we have the bigger circle and the smaller circle. AB is our first tangent. So, the bigger circle lies on the left side and the smaller circle lies on the right side of the tangent. When you take this tangent CD, we have the bigger circle to the left side of the tangent and smaller circle to the right side of the tangent. Clear? So, when a tangent common to two given circles is drawn in such a way that both the circles are on the either side of it, the tangent is called transverse common tangent. Here again, the length of tangents will be same. That is, AB will be equal to CD. That is, tangent touching the circle at points when we measure the distance A to B distance, it will be equal to C to D distance. Understood? Let us take an example. In triangle PQR, PQ is equal to 24 centimeters, QR is equal to 7 centimeters and angle PQR is equal to 90 degrees. Find the radius of the inscribed circle. Here we have a triangle PQR and a circle is inscribed within the triangle. Okay. We have to find the length of this radius of the circle. I have taken the length as x. Okay. X is the radius of circle. Now, when you consider this, it is given that PQR is 90 degree and the measure of PQ, side PQ of the right triangle is 24 centimeter. This length is 24 centimeter and QR is equal to 7 centimeter. Okay. Now, consider right triangle. Consider right triangle PQR. We'll be having PQ square plus QR square is equal to PR square. That is, we are applying Pythagoras theorem here. Pythagoras theorem. On applying Pythagoras theorem, we'll be having PQ square, which is the height, QR square, base is equal to PR square. PR is the hypotenuse. Okay, PQ is equal to 24. 24 square plus QR is 7. 7 square is equal to PR square. Then 24 square we get 576 plus 7 square is 49 is equal to PR square, which means PR square is equal to 576 plus 49 we get 625 and PR is equal to root of 625. What is root of 625? 625 is a perfect square and root of 625 is equal to 25 centimeter. So, this length PR is equal to 25 centimeter. Now, here when you take this PQ, there is a point on this side which touches the circle. Okay, so this is a tangent to the circle. Yes. Now I am marking this point as some S. Okay. Now, when you take this QR, there is a point where the circle touches this side. I am taking this as T. And here again, when you take this side, PR, the circle touches at this point. We'll take this point as some U. Okay. Now, when I consider this small figure, OSQT. OSQT is a square. Why? Because this Q is an exterior point, and from this exterior point there are tangents drawn to circle. Okay. So the length of tangents should be equal. Therefore, QS will be equal to QT. Length of tangents from an exterior point are always equal. Okay. So, we have SQ and QT equal. Now, these angles are right angles. Why? This is the radius and this is the tangent. We know the angle between the radius and tangent will always be equal to 90 degree. Here again, OT and QT are perpendicular to each other. Yes. Therefore, all the angles, all the sides have equal angles and the angle is equal to 90 degree. Therefore, this figure is a square. OSQT is a square. So, we know that for a square, all the sides will be equal. Length of sides should be equal. Yes. So, in order to find this x, that is the radius of circle, we need to find any of this length of tangent. This is x, this is x, this is x and this is x. Okay. Now, here we have the total length PQ is equal to 24 centimeter. PQ is equal to PS plus SQ. Okay. Then what is PS? PS can be written as PQ minus SQ. PQ we have PQ. Total length is equal to 24 centimeter. 24 minus SQ. The small length is X. 24 minus X. Similarly, when you take this part, here QR is equal to QR is equal to QT. QR is equal to QT plus TR. Then what is this TR? TR will be equal to QR minus QT. We have QR. QR is 7 centimeter. 7 minus QT. QT is the small length which is X. Okay. Now this PS. PS is a tangent. Similarly, from this point another tangent is drawn to the circle, that is PU. Therefore, PS will be equal to PU. Okay. Measure of PS is 24 minus X, which means PU is also equal to 24 minus X. Similarly, here RT is a tangent. RT is equal to 7 minus X. From the same point, exterior point R, we have another tangent which is RU. Therefore, we will be having TR is equal to RU. Therefore, RU is equal to 7 minus X. Now, we know the total length. Yes, PR. PR. PR is equal to PU plus UR. What is PU? PU is equal to 24 minus X and UR. UR or RU is equal to 7 minus X plus 7 minus X is equal to PR. What is PR? PR we have determined, which is the hypotenuse of the right triangle, 25 centimeter. That is 25. Okay. Therefore, 25 is equal to 24 minus x plus 7 minus x. 25 is equal to 24 plus 7, we get 31, minus x minus 2x. Taking this minus 2x to left hand side and 25 to the right hand side, we get 2x is equal to 31 minus 25. 2x is equal to, what is 31 minus 25? 6. Which implies x is equal to 6 by 2 and that is equal to 3. What is x? X is the radius of the circle. In the question, we are asked to find the radius of the inscribed circle. Therefore, radius is equal to, radius of circle is equal to 3 centimeter. Clear? We are getting the radius of circle 3 centimeters. Let us take another example. P and Q are centers of circles with radii 9 centimeter and 2 centimeter respectively. PQ is equal to 17 centimeter. R is the center of a circle of radius x centimeter which touches the above circles externally. Given that RPQ, angle RPQ is equal to 90 degree, write an equation in x and solve it. Here, this is how you will be getting a figure. First, you need a circle with radius 9 centimeter. This is the figure with radius 9 centimeter. Then you need another circle with radius 2 centimeter. This is the circle with 2 centimeter radius. We have PQ is equal to 17 centimeter. PQ, P and Q centers of the two circles. When joined, you will be getting 17 centimeters. R is the center of a circle of radius x. This is the circle of radius x and R is the center which touches both the circles externally. Externally, it is touching both the circles. Yes, we are given that PRQ is equal to 90 degree. PRQ, this angle is 90 degree. We have to write an equation in x and find the value of x. X is the radius of the circle with center R. Okay. Here, when you consider triangle PQR. Given that angle PRQ is equal to 90 degree, which means PQ will be the hypotenuse. We have side opposite to right angle will be the hypotenuse. PQ is the hypotenuse and we know the measure of PQ. Yes. What about PR? PR will be equal to this 9 centimeter plus x centimeter because they are touching externally. R1 plus R2. Okay. This distance between the centers of circle will be radius of first circle plus radius of the second circle. We have PR is equal to 9 centimeter plus x centimeter. Similarly, what is RQ? RQ will be equal to x centimeter plus 2 centimeter. This is the radius of first circle and this is the radius of second circle. We have the distance between the centers. RQ is equal to radius of first circle plus radius of second circle, that is x plus 2. Okay, x centimeter plus 2 centimeter. Now, hypotenuse is equal to PQ and that is 17 centimeter. Applying Pythagoras theorem. We have PQ square is equal to PR square plus RQ square. PR square plus RQ square. Okay. Now put the values. PQ square 17 square is equal to PR square. PR is 9 plus x. 9 plus x square plus RQ square. RQ is 2 plus x. 2 plus x whole square. Okay. What is 17 square? 17 square is equal to 289. 289 is 9 plus x whole square. A plus b whole square is equal to a square plus 2ab plus b square. Here in position of a we have 9 and in place of b it is x. 9 square 81 plus 2ab. 2 into 9 18 into x 18x plus b square is x square. X square plus this part 2 plus x whole square 2 square 4 plus 2 into 2 into x, 4x plus x square. 289 is equal to 81 plus 4 we get 85. 18x plus 4x. 18x plus 4x is equal to plus 22x plus x square is 2x square. Okay. That is 2x square plus 22x plus 85 minus 289 will be equal to 0. We are taking all the terms to one side and right hand side we are making 0. 2x square plus 22x minus 204. 85 minus 289 we get minus 204, that will be equal to 0. So this is the required equation. Now we can simplify this equation, that is here 2 is common. Now I am dividing throughout by 2. Dividing by 2. What we get? X square plus 22x by 2 is 11x minus 204 by 2, 102 will be equal to 0. So this is the required quadratic equation in terms of x. To find the value of x, our equation is x square plus 11x minus 102 is equal to 0. Okay. Now we will perform the splitting middle term method. Here middle term we have 11, that is the sum of two numbers should be 11 and its product should be equal to minus 102. When do we get negative product? You have one number positive and the other number negative. Only then you will be getting negative here. Okay. So one number should be positive and the other should be negative. Here sum is positive, which means the greater number is positive. When we take 17 and 6, 17 into 6 is 102. Okay. You need to get 11. The sum is 11, which means the greater number should be positive. 17 should be positive and 6 should be negative. 17 minus 6 is 11 and 17 into minus 6 is minus 102. Putting the values, x square splitting 11x2 plus 17x minus 6x minus 102 is equal to 0. Okay. Now here considering these two terms, x is common, x plus 17. What about here? Here when you take the third and fourth term, we can take minus 6 outside. Remaining we have x plus 17, that is equal to 0. Okay. Now x plus 17 is common to both the terms. Taking x plus 17 out, we have x minus 6 remaining and that is equal to 0. 0 product rule. Either x plus 17 is equal to 0 or x minus 6 is equal to 0. Then x is equal to minus 17 or x is equal to 6. Now what is x? X is the radius of the circle. Can radius be negative? Negative radius is not possible. Since x is the radius of circle with center R, the value of x should be positive, which means acceptable value is x is equal to 6. Radius of circle with center R is equal to 6 centimeter. Clear? 6 centimeter. Next, example 3. This is a question that came for ICSE Board Exam 2020. In the given figure, TP and TQ are two tangents to the circle with center O touching at A and C respectively. If angle BCQ is equal to 55 degree and BAP is equal to 60 degree, find OBA and OBC, then AOC and ATC. Here BCQ is equal to 55 degree. BCQ, this angle is 55 degrees. Then BAP is equal to 60 degree. BAP is this angle and that is equal to 60 degrees. First we have to find OBA and OBC. OBA, this angle, and OBC, OBC, this angle. Okay, let's start. So the first one, Here given that angle BCQ is equal to 55 degree and BAP is equal to 60 degree given. Okay. Now here OA and OC are the radius of the circle. Yes. And this PT and QT are the tangents to the circle. So we know that the angle between radius and tangent will always be equal to 90 degree. Therefore, this OAP, angle OAP will be equal to 90 degree. Similarly, OCQ will also be equal to 90 degree. OCQ is equal to 90 degree. What is the reason? Angle between radius and tangent at a point is right angle or is equal to 90 degree. Okay. OAP. Here OAP. This angle is made of OAB and PAB. Yes. We can write angle OAP is equal to angle OAB plus angle BAP. We know what BAP is. It is given in the question. It is equal to 60 degrees. Also, OAP we have 90 degree, which means we can find OAB. OAB will be equal to angle OAP minus angle BAP. Put the values. OAP. OAP is 90 degree. 90 degrees minus BAP. BAP is 60 degree. 60 degree, that is equal to OAB is equal to 30 degrees. We are getting OAB 30 degrees. Now OA and OB. Just take OA and OB. OA and OB are the radius of circle. Radii of circles will be having same measure, which means OA is equal to OB. Reason? Radii of circle. Okay. If OA and OB are equal, then the angle opposite to them should also be equal. Angle opposite to equal sides are equal. Therefore, OA opposite to OA, we have angle OBA. Angle OBA equal to OB. Opposite to OB, we have OAB. Angle OAB. Then what is angle OAB? OAB we have determined is 30 degree. OBA will also be equal to 30 degree. Yes. Angle OBA is equal to 30 degree. So we determined OBA. What about OBC? To find OBC, take this entire angle. Angle OCQ. OCQ will be equal to OCB. Angle OCB plus angle BCQ. BCQ. Okay, BCQ is given 55 degrees. What about OCB? OCB. We have to find OCQ is 90 degree. Okay, since OC perpendicular to TQ, tangent TQ, will be having angle OCQ equal to 90 degree. Then we have to find angle OCB. Angle OCB equal to angle OCQ minus angle BCQ. Put the values. OCQ. 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 OCQ is equal to 90 degrees. 90 degree minus BCQ. BCQ is 55 degrees. 55 degrees. 90 minus 55, we get 35 degrees. So this angle is 35 degrees. Here again OC and OB are radius of circle. So we will be having OC is equal to OB. Radii of circle. Therefore the angle opposite to them should also be equal. Opposite to OC we have OBC. Opposite to OB we have OCB. OCB is equal to 35 degree. Therefore OBC, angle OBC should also be equal to 35 degrees. Okay, so we got the angle OBC. OBC is also equal to 35 degrees. Here OBA is 30 degree and OBC equal to 35 degrees. Now the second part we have to find AOC. Here we have AOC, this angle. How to find AOC? When you consider this arc AC, AC subtends angle AOC at the center and ABC on the circumference of circle. Okay, therefore we will be having angle AOC is equal to 2 times angle ABC. What is the reason? Angle subtended by an arc at the center is twice the angle subtended on the circumference. So do we know what ABC is? ABC will be equal to OBA plus OBC. Yes, angle ABC is equal to angle OBA plus angle OBC. Now put the values. Here OBA is 30 degree and OBC is equal to 35 degrees. Plus 35 degrees, that is equal to 30 plus 35 degree, 65 degrees. So this angle is 65 degrees. Therefore angle ABC is equal to 65 degrees. So this complete angle is equal to 65 degrees. Okay. When ABC is equal to 65 degree, what is AOC? AOC will be, angle AOC will be equal to 2 times angle ABC, that is 2 into 65 degree equal to 130 degrees. The measure of AOC is 130 degrees. Next what? We have to find angle ATC. To find ATC, consider quadrilateral ATCO. ATCO. We know that the sum of the angles of a quadrilateral will be equal to 360 degrees. So here we have this angle 90 degree and this angle 90 degree. Why? Because the angle between the radius and tangent will always be equal to 90 degree. Therefore, angle OAT equal to angle OCT, that is equal to 90 degree. And we have AOC, which we have determined, is equal to 130 degrees. 130 degrees. So we have to find ATC. Angle ATC plus angle AOC plus OAT plus OCT is equal to 360 degrees. Now put the value. Angle ATC plus AOC 130 degree plus OAT 90 degree plus OCT 90 degree is equal to 360 degrees. Okay. Angle ATC plus 130 plus 90 degree 220. 220 plus 90 degree is equal to 310 degrees. 310 degree is equal to 360 degree. Therefore, ATC is equal to 360 degree minus 310 degree, and that is equal to 50 degrees. Okay. The measure of this angle ATC is 50 degrees. Clear? So, we have determined OBA, OBC, AOC and ATC. Understood this? Example 4, this is a question that came for ICSE Board Exam 2019. In the given figure, AC is a tangent to the circle with center O. If ADB is equal to 55 degree, find X and Y. Give reasons for your answer. Here, given that ADB, angle ADB is equal to 55 degree. We have to find the values of X and Y. Okay. Given angle ADB is equal to 55 degree. Now when you consider triangle ABD, okay, in triangle ABD, this angle is the right angle. What is the reason? OA is the radius and AC is tangent. Angle between the radius and tangent will be equal to 90 degree. Consider triangle BAD. Triangle BAD. In triangle BAD, we have angle ADB is equal to 55 degree. Angle BAD is equal to 90 degree. That is angle between radius and tangent is a right angle. Is a right angle. Okay. BAD. Then we can find angle ABD. Yes. Angle ABD plus angle BAD plus angle ADB will be equal to 180 degree. Sum of interior angles of a triangle is 180 degrees. Okay. Now put the values. ABD. ABD we have to find angle ABD plus BAD. BAD is 90 degree plus BDA is equal to 55 degree is equal to 180 degrees. That is ABD plus 90 plus 55 degree, we get 145 degree is equal to 180 degree. ABD will be equal to 180 degree minus 145 degrees. What is 180 minus 145 degree? We get 35 degree. Angle ABD is equal to 35 degrees. 35 degrees. So once you get ABD, we can find what AOE, this angle, that is Y is. What is the relation? Here this arc AE subtends angle AOE at the center and ABE on the circumference of circle. We have angle AOE is equal to 2 times angle ABE. Angle subtended at center is double the angle subtended on the circumference. Double the angle subtended on the circumference. Therefore, angle AOE is equal to 2 times 35 degree. What is AOE? AOE is the required angle Y. Y is equal to 2 into 35 degrees, that is equal to 70 degrees. We are getting Y is equal to 70 degrees. Clear? Y is equal to 70 degrees. Okay. Now, when you take this triangle ACO, here in ACO we know OAC is equal to 90 degree and AOC is angle Y. Then we can find the value of X. Yes. Consider triangle ACO. In triangle ACO, we have angle OAC is equal to 90 degree and angle AOC is equal to Y, which is equal to 70 degrees. 70 degrees. Therefore, we have angle OAC plus AOC plus ACO. Angle ACO is equal to 180 degree. Again, sum of interior angles of a triangle will be equal to 180 degrees. Now, put the values. OAC 90 degree plus AOC that is 70 degree plus ACO we have to find and it is X. X is equal to 180 degrees. 90 plus 70, we get 160 degrees plus x is equal to 180 degree and x is equal to 180 degree minus 160 degree, which is equal to 20 degrees. Okay. Angle x is equal to 20 degrees. So, we have determined x and y. X is equal to 20 degrees and y is equal to 70 degrees. Clear? Let us solve problems from exercise 18A. Here we have the first problem. Question 1 of exercise 18A. The radius of a circle is 8 cm. Calculate the length of a tangent drawn to the circle from a point at a distance of 10 cm from its center. Consider a circle. So, this is circle with center O. Given the radius of circle is 8 cm. Here we have the radius 8 cm. We have a point. Let us take this point as P outside the circle, which is at a distance of 10 cm from the center. Okay. From this point P, I can draw a tangent. So, this point I will be marking as T. So, PT is a tangent to the circle. Now, we know that the tangent to a circle at a point and radius at that point will be perpendicular to each other. Therefore, this angle will be equal to 90 degree. Yes? Tangent to a circle at a point and the radius at that point will be perpendicular to each other. Now, we have OT is equal to 8 cm, which is the radius of circle. OP is equal to 10 cm, the length that is given, that is there is a point P which is at a distance of 10 cm from the center and center we have taken as O. TP is the tangent. Okay. We have to find the length TP. Now consider the triangle OTP. This triangle OTP is a right triangle. Yes, we have a angle equal to 90 degree. Therefore, this is a right triangle. Consider right triangle OTP. Okay. In this right triangle OTP, OP is the hypotenuse. The side which comes opposite to the right angle is the hypotenuse. Now, we have Pythagoras theorem. We can apply Pythagoras theorem. According to Pythagoras theorem, we will be having OT square plus TP square will be equal to hypotenuse square. Base square plus height square is equal to hypotenuse square. Here base I have taken as OT and TP is the height. OP is the hypotenuse. OP square. Okay, we need to find TP. TP square will be equal to OP square minus OT square. Put the values. What is OP? OP is 10 cm. TP square is equal to 10 square minus OT square 8 square. TP square is equal to 10 square 100 minus 8 square 64. TP square is equal to 100 minus 64, we get 36 and TP is equal to root of 36, that is equal to 6 cm. Therefore, the length of tangent is equal to 6 cm. We have determined the length of tangent TP, that is 6 cm. Understood this? Let's move on to the second problem. Problem 2, question 4 of exercise 18A. Two circles touch each other internally. Show that the tangents drawn to the two circles from any point on the common tangent are equal in length. Here I have taken two circles. One is this circle with center O and the second is this bigger circle with center O dash. Okay. Now, QP, this is a tangent that touches both the circles at point P. Okay. Now, when you consider the small circle, we have two tangents, QP and QA. Yes, we know that the tangents from the same exterior point will be of equal length. Consider circle with center O. QP is a tangent. QP will be equal to QA. That is, tangents from the same exterior point will be of equal length. Okay, so QP is equal to QA. So this is my first equation. Now when I consider the bigger circle, that is, consider circle with center O dash. We have QP is equal to QB. Okay, QP is equal to QB. So QP is a tangent to the bigger circle and QB is also a tangent drawn to the bigger circle. They are from the same exterior point Q. Therefore, they will be of equal length. QP is equal to QB. I am taking this as 2. Okay. Now compare 1 and 2. Left hand side we have QP. Therefore, right hand side should be equal. QA will be equal to QB. So in the construction, what we have done, we have taken two circles which touch each other at a point. Now, there is a common tangent. QP is the common tangent we have taken. P is the point where the tangents meets the circle. We have taken two other tangents from a common point. From Q, we have taken QA as the tangent to the smaller circle and QB as the tangent to the bigger circle. And we have proved that QA is equal to QB. That is, tangents drawn to the two circles from any point on the common tangent. Point on common tangent is Q, are of equal lengths. The tangents are QA and QB. QA and QB are of equal length. Tangents drawn from common point are of equal length. Okay, so we have proved this. Clear? Next, problem number 3, question 5 of exercise 18A. Two circles of radii 5 cm and 3 cm are concentric. What are concentric circles? Circles with same center and different radii are called concentric circles. Calculate the length of a chord of the outer circle which touches the inner circle. Here, this is my outer circle and this is my inner circle. These are concentric circles with center O. Here, I am taking this radius. Let us take this point as some t. Here, this radius is given as 3 cm. That is the radius of smaller circle. And the radius of the bigger circle is 5 cm. Let us take this as a point S. Okay. I am drawing a line which is a tangent to the smaller circle. What is given in the question? We have to calculate the length of a chord of the outer circle which touches the inner circle. So, this is a chord. Let us name it as SP. Okay. SP is a chord of bigger circle or the outer circle and it touches the inner circle. Since it touches the inner circle, this is a tangent to this circle. Yes, it is a tangent to the smaller circle. How to find the measure of this chord? We have to find the length SP. How to find SP? Here we can first find ST, right? What is the relation between ST and SP? When you take this point center and draw a line perpendicular to chord of a circle, we have studied the perpendicular bisects the chord. Yes, therefore, we will be having SP is equal to 2 times ST. Bisect means it will be divided into two equal halves. ST and PT will be equal. ST plus PT will be equal to SP. Therefore, ST will be half of SP, or we can write SP is equal to 2 times ST. Okay. So, if we are able to find the length ST, we can get the length SP. How to find ST? So, here this is a right triangle. Yes, because this is the radius and this is tangent. Tangent at a point will be perpendicular to the radius of the circle. So, this angle is 90 degree. In right triangle OST, we are applying Pythagoras theorem. Pythagoras theorem. Okay, here we have 90 degree. Opposite to 90 degree, we have side OS. Therefore, OS is the hypotenuse. We have OT square plus TS square is equal to OS square. OS is the hypotenuse. Now, to find TS or ST, TS square will be equal to OS square minus OT square. What is OS? OS is 5 centimeter. 5 square minus OT. OT is 3 centimeter. 3 square equal to TS square is equal to 5 square 25 minus 3 square 9. 25 minus 9 we get 16. Therefore, TS is equal to root of 16 and that is 4 centimeter. We are getting this length. TS 4 centimeter. Then what is SP? SP is equal to 2 times ST. ST we have found, which is 4 centimeter. ST and TS are the same, 4 centimeter. Therefore, 2 into 4 centimeter equal to 8 centimeter. 8 centimeter is the total length SP. What is SP? The length of the chord of the outer circle which touches the inner circle. Clear? Next, problem 4, question 9 of exercise 18A. From the given figure, prove that AP plus BQ plus CR is equal to BP plus CQ plus AR. Second, we have to show that AP plus BQ plus CR is equal to half into perimeter of a triangle ABC. So, here we have triangle ABC. We have an inscribed circle and the circle touches side AB at point P, BC at point Q and AC at point R. Okay. Therefore, these are tangents. Yes, tangents to the circle. Now, we know that the tangents to circle from an exterior point will be having the same measure. Yes, therefore, we can write AP is equal to AR. What is the reason? Tangents from an exterior point will be of equal length. Will be of equal length. So, we got AP is equal to AR. Okay, take this as 1. AP is equal to AR. Now, when you consider this point B, here we have two tangents BQ and BP. Therefore, we will be having BQ is equal to BP. Same reason, this I am taking as 2. Similarly, when you take this point C, CR is the tangent and CQ is the second tangent. So, the length CR and CQ will be equal. CR is equal to CQ. Same reason, this is our third one. Okay. Now, what I am going to do is, I am going to add equation 1, 2 and 3. Adding 1, 2 and 3. First, we will add the left hand side. LHS, here we have AP, AP plus. From the second equation, we have BQ, BQ plus. Third equation, we have CR. CR is equal to, here we have AR in the right hand side plus. Here we have BP in the second equation, right hand side plus. Here we have CQ. CQ. Okay. So the first thing what we had to prove is AP plus BQ plus CR. Left hand side, AP plus BQ plus CR is equal to BP plus CQ plus AR. BP plus CQ plus AR. So this proof is clear. Okay. Now we have to show that AP plus BQ plus CR is half of the perimeter of triangle ABC. What is perimeter of triangle? Perimeter is the sum of the length of sides of the triangle. Here what I am going to do is, I am going to add AP plus BQ plus CR on both sides. Adding AP plus BQ plus CR on both sides. What do we get? Here, left hand side, we already have AP plus BQ plus CR. Again adding AP plus BQ plus CR. What about right hand side? Right hand side we have AR plus BP plus CQ plus AP plus BQ plus CR. Okay. AP plus AP is 2AP. 2AP plus BQ plus BQ 2BQ plus CR plus CR 2CR. 2CR is equal to. What about right hand side? Here we have AR and CR. AR plus CR. AR plus CR. Then here we have BP and AP. BP plus AP plus CQ. Here we have CQ and BQ. BQ. CQ plus BQ. 2AP plus 2BQ plus 2CR can be written as 2 into AP plus BQ plus CR is equal to AR plus CR. AR is this and CR is this. That is AC. AR plus CR gives us AC. AC plus BP plus AP. BP, AP. We get side AB plus CQ plus BQ. CQ is this and BQ is this. We will get BC plus BC. Okay. What is this AC plus AB plus BC? AC plus AB plus BC. This is a perimeter of triangle. So 2 times AP plus BQ plus CR is equal to perimeter of triangle ABC. Here we have a 2. Taking this 2 to the opposite side. Multiplication becomes division. That is AP plus BQ plus CR is equal to half into perimeter of triangle ABC. Hence proof. So this is what we had to show. Clear? Next, problem number 5, question 18 of exercise 18A. In the following figure, PQ and PR are tangents to the circle with center O. If angle QPR is equal to 60 degree, calculate QOR, OQR and QSR. QPR is given which is 60 degrees. Okay, first we have to find QOR, this angle QOR. How to find QOR? For the first part, we have, consider this figure that is QORP. This is a quadrilateral. Yes. Now, what is the angle OQP? We have OQ is the radius and QP is the tangent. Therefore, OQ will be perpendicular to QP. Yes, OQ perpendicular to QP. Here, OR is the radius and RP is tangent. Therefore, OR is perpendicular to RP, which means angle OQP is equal to angle ORP equal to 90 degrees. Okay, so we know inside a quadrilateral the sum of angles will be equal to 360 degrees. Yes, consider quadrilateral OQPR. Sum of angles, that is angle OQP plus angle QPR plus angle ORP plus angle QOR will be equal to 360 degrees. Sum of angles of a quadrilateral will be 360 degrees. Put the values. OQP will be 90 degree. Similarly, ORP is also 90 degree. OQP 90 degree. Then QPR is given, that is 60 degree, plus ORP is 90 degree, plus what we have to find, that is QOR will be equal to 360 degrees. 90 plus 90, 180, 180 plus 60, 240. 240 degree plus QOR is equal to 360 degree, which means angle QOR equal to 360 degree minus 240 degree, and that is equal to 120 degrees. Okay, this angle QOR is 120 degree. Now the second, we have to find angle OQR. To get OQR, I am drawing a line. Okay, that is join QR. Points Q and R when joined, only then we will be able to get angle OQR. This angle. How to find? Now consider triangle OQR. We know angle QOR is equal to 120 degree. Here OQ and OR are the radius of circle. Therefore OQ will be equal to OR, radii of circle. Okay. From this we know that angles opposite to equal sides should be equal. Opposite to OQ we have angle ORQ will be equal to, opposite to OR we have OQR. Angle OQR. Okay. If I am taking this OQR as some x, then ORQ will also be equal to x. Now we have the sum of interior angles of a triangle equal to 180 degree, that is x plus this 120 degree, that is QOR. 120 degrees is equal to 180 degree. 2x plus 120 degree equal to 180 degree. The reason, sum of interior angles of a triangle is 180 degrees. Okay. 2x will be equal to 180 degree minus 120 degree. 180 minus 120 we get 60 degrees. That is 2x is equal to 60 degree and x is equal to 60 divided by 2. 60 degree by 2, which is equal to 30 degrees. Okay. This measure is 30 degree angle x, that is OQR is equal to 30 degrees. Next, the third part, we have to find angle QSR. Finding QSR is very simple, right? We know what QOR is. QOR is equal to 120 degree. We have angle QOR is equal to 2 times angle QSR. What is the reason? Angle subtended by an arc at the center is double the angle subtended on circumference. Okay. Here the arc QR is subtending angle QOR at the center and QSR on the circumference of circle. Now put the value. QOR is equal to 120 degree, that is 2 times QSR, which means angle QSR is equal to 120 degree divided by 2 and that is equal to 60 degrees. QSR is equal to 60 degrees. Clear? Next problem number 6, question 20 of exercise 18A. In quadrilateral ABCD, angle D is equal to 90 degree, BC is equal to 38 centimeter and DC is equal to 25 centimeter. A circle is inscribed in this quadrilateral which touches AB at point Q such that QB is equal to 27 centimeter. Find the radius of the circle. First, we'll take a quadrilateral ABCD. So, this is ABCD. We have a circle which is inscribed in this quadrilateral. What else is given? A circle is inscribed in this quadrilateral which touches AB at point Q. AB at point Q. So, this is the point where the circle touches AB. We have QB is equal to 27 centimeter. QB is this measure. This is 27 centimeter. Okay, what else is given? The measure BC is given. BC is equal to 38 centimeter. BC is this total length and that is equal to 38 centimeter. Also DC is given. DC is equal to, this whole measure is 25 centimeter. One more thing, angle D is equal to 90 degree. This angle is 90 degree. We have to find the radius of the circle. Let us take, this is the center of circle. We need to find the radius of circle. Okay. Now let us take points. Here we have point P. This is Q. This is R. And this is S. These are the points where the circle touches the sides of quadrilateral ABCD. Now, here QB is given, that is 27 centimeter. Then what is the measure of BR? Is there any relation? When you consider this external point B from this exterior point, BQ is a tangent and BR is also tangent to the circle from the same exterior point. Therefore, the length of tangent should be equal. We will be having BQ is equal to BR. What is the reason? Tangents from the same exterior point to the circle is of equal length. Okay, then what is BR? BR will be equal to, BR is equal to 27 centimeter. Here BR is equal to 27 centimeter. We know the measure BC. We can find RC, right? We have BC is equal to BR plus RC. Therefore, RC is BC minus BR. BC, the total length BC is equal to 38 centimeter. 38 minus BR, the small length we have found, which is 27 centimeter. 27 centimeter. What is 38 centimeter minus 27 centimeter? We get 11 centimeter. Therefore, RC is equal to 11 centimeter. If RC is 11 centimeter, then SC will also be equal to 11 centimeter. From this exterior point C, two tangents are drawn, CR and CS to the circle. Therefore, the length of tangent should be equal. CR will be equal to CS. CR is RC, RC is 11 centimeter. Therefore, CS is also equal to 11 centimeter. If CS is equal to 11 centimeter, we can find the length DS. Yes, we have DC is equal to DS plus CS, which means DS is equal to DC minus CS. Okay, DC is 25 centimeter, 25 minus CS. CS we have determined, which is 11 centimeter. 25 minus 11, which is equal to 14 centimeter. Okay, we got DS is equal to 14 centimeter. If DS is equal to 14 centimeter, then DP will also be equal to 14 centimeter. DS is equal to DP. Tangents from same exterior point is of equal length. Okay, therefore, what is DP? DP will be equal to 14 centimeter. Okay, we have DS 14 centimeter and DP 14 centimeter. This angle is 90 degree. Now, I am joining this. So, we have OS is one radius and OP is another radius. Radius and this line is a tangent. DS is a tangent. Therefore, we know that the angle between radius and tangent will be 90 degree. So, this is a right angle. Yes. Similarly, here we have OP and DP. DP is tangent and OP is radius. Therefore, the angle between them will be 90 degree. If all these are 90 degree, then this should also be 90 degree. Total sum should be 360 degree. Okay. So, we have all angles 90 degree and the adjacent sides equal, which means this figure is a square. OSDP is a square. We know for a square, all the sides should be equal. We have determined two sides. If this and this are 14 centimeter, then OP will be 14 centimeter. Similarly, OS will be 14 centimeter. Okay, OS and OP are radius. OS is equal to 14 centimeter. Therefore, radius of circle is equal to 14 centimeter. Radius of circle is equal to 14 centimeter. Understood? That's all for today. In today's class, we have discussed tangents and intersecting chords. We have solved questions from exercise 18A. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.